Alright, gonna finish up with two more examples. The first one will be number 5 from our 5.3 worksheet, where we have to solve by using identities. And looking at this equation to start, not too much we can do right now since the identities don't match. We can't isolate sine or cosine, and we can't just factor the way it is. So we want to try to get the same trig function. And looking at this, really the only option for identities I have is this sine squared, but that's pretty helpful because we can replace sine squared with our Pythagorean identity 1 minus cosine squared. So I'm going to throw that in there. I'll write out everything else, and I'll simplify this guy. Get things all situated here. And then again, just going to simplify through. To a point where I can factor. Now, I think I'm going to move these guys onto the other side. I just don't like to have that -2 cosine. So I'm going to flip sides for everything. So I'm going to put my 0 over here. I'll get a +2 cosine squared plus, I think I paused my recording, so we'll see what happens in the jump, but I'm just moving everything to the other side of this equation. So I've got my +2 cosine plus cosine squared. 2 minus 1 over there would be 1, so I think I've got a -1 over here. And then hopefully this guy factors. So it would factor into 2 cosine x. I know I'm going to have a 1 and a cosine. And I think I need the, let's see, 2 cosine squared, 2 over here. And then I'm hoping that looks good. 2 cosine squared, -2, plus, nope, I gotta flip them. Hopefully you're yelling at me. So +2 minus 1, that looks good now. Alright, and then this kind of picks up just like we were doing before, so I'll have cosine x equals +1/2, and cosine x equals -1. And again, for this one, we just want solutions on the interval from 0 to 2 pi. So I'm going to think about where these situations happen. So our first one, +1/2, would be in quadrant 1 at pi over 3. And then we'll have our answers in quadrant 4 at 5 pi over 3. And cosine's -1 only at one spot on our unit circle. Right, that would be over here when x is -1 at pi. So I'll have those 3 answers. We can check with our answer key at the end there. I think we're looking pretty good. And we'll be set. So I'm going to have you guys try out the other ones in this section on your own. Remember, we still have all the other, I guess, identities and strategies we use, like factoring. You can simplify first, whatever you can do to get through that. But I'm going to do one more example from this packet, and it's going to be from that last section where it's solved by squaring. Just make this a little bit bigger for us here. Alright, we'll go with this. Okay, so I kind of gave us a little info to start and walked us through the first couple steps. But when you look at this problem, it says solve for all values of the variable. And starting off, cosecant minus cotangent equals 1. I can't isolate either trig function. If I used identities, we'll get cosecant is 1 over sine, cotangent is cosine over sine. So you actually could like factor out a cosecant, but since there's not a 0 on the other side, factoring isn't really going to help us that much in this situation. So I did have the first step for us here. I said move one function over to the other sides, so it's easier to FOIL, and we don't have to FOIL it yet. But now, when we square both sides, that's what I'm going to do next. Get a new color here. So I'll have cosecant squared on this side. Don't forget, when you square the right side, that's when we have to FOIL. And it's just a little bit nicer because we don't have 2 trig functions there. So I'll get 1 plus 2 cotangent plus cotangent squared. And then this actually becomes just like the problem we did where we want to try to match the trig functions first. So we've got a lot of cotangents over here. Luckily for us, cosecant can also be a cotangent. So I'm going to rewrite this guy and go below this writing here. So cosecant squared will be 1 plus cotangent squared. And then I'll have the same thing on the other side here. And now I can simplify, move everything over, write my 1's cancel, my cotangents cancel. So not a lot going on with this. And at the end, we'll get 0 equals 2 cotangent x, or just cotangent x. Okay, so there is one kind of stipulation with these square both sides, and it says on the worksheet, I gave you a lot of space. Finish solving and check your solutions. Now, when we square both sides at the beginning, so here, when you square it, it doesn't matter, right, if it was positive or negative at the beginning. It's pretty much like just making everything positive. So we need to double check that all of the answers would actually satisfy that original equation. So for cotangent, we want to think about like what regular angles, what angles in the unit circle does cotangent equal 0? And cotangent, we know, is cosine over sine. So I'm really thinking about where the cosine equals 0, which is up top at pi over 2 and down the bottom at 3 pi over 2. Now we only need to check these two answers because everything else would be coterminal angles of these, where all the values would be the same for any trig function. So I'm going to take these and put them either back in the original equation or the one that we moved to both sides. I think I'm going to do the second one just because I don't like, again, the trig functions on both sides. So we're doing cosecant, rewrite this out for us, equals 1 plus cotangent. Make sure I wrote that right, looks good. And we're going to sub it in. So cosecant of pi over 2, let me put my coordinate up here, that'll help me out. It's going to be 1. And then cotangent of pi over 2 we figured out was just 0. So pi over 2 works, that's good, along with all of its coterminal angles. So that's definitely going to be one solution. And let's do the same thing for 3 pi over 2. That would be our coordinate, 0, negative 1. So cosecant is going to be negative 1, but cotangent is 0. That guy doesn't work. And again, it's when we squared that, like negative 1, when we squared that cosecant, we didn't take into account the signs originally, so that would be an extraneous solution for us. So the only time you have to check is when you square both sides. Of course, it's good practice in general, but there you guys go. You can try out the rest and check your answers. Good luck.